Good morning, everyone. My name is Kevin. Thank you for attending the Collector for ArcGIS high accuracy data collection presentation. So, kind of a little bit before I get started. So, you can successfully perform high accuracy workflows across all platforms that Collector supports. So, Windows, iOS, and Android. For those of you who aren't familiar with iOS, we have two versions of our app that are currently available in the store: Collector Classic for ArcGIS and Collector for ArcGIS, which is the new version. I'm going to be doing most of my demonstrations using the new version of Collector on iOS, with the exception of some with certain functionality that I'm going to be demoing. A lot of this is already available in the classic versions as well. So let's go ahead and get started. So kind of what we're going to be doing today, we're going to be going through getting started, which includes some considerations to make before performing a high accuracy data collection. Also, I'm going to go through a demo about how we can go through the settings and set up like your different datum transformations and your required accuracy values and things like that. Then we're going to go into a field data collection process where obviously I can't do it live, but I have a video recording that I captured before I came here, which I'm going to talk through, so you can kind of get a sense of how we set up the receiver, how we wait to get the good accuracy that we want, and how we actually do the data collection that we need. Then we're going to go into using offsets to capture features, and I'll go into a little bit more in that when I get there, and then we'll have some Q&A at the end. So, some data collection considerations that we should be making. Before I get into each of these bullet points, what I mean by high accuracy, because a lot of that term is kind of ambiguous, is that any project that is constrained by certain requirements. So your project requirement might be sub-meter, somebody else's might be centimeter level, but there's still requirements to get this project done, so therefore we would dub that as a high accuracy project. Because you need some way to get reliable accuracy for your field collection to be successful. So that would come into the project accuracy requirements. A lot of the times the project is driven by that, and like I just mentioned, you may even fluctuate between project accuracy requirements on a monthly basis, where you'd be like, this project, or a project basis, I need centimeter level for this project, but I don't need centimeter level for this project. So maybe there's a solution that can fit both scenarios where you don't have to buy equipment that you don't necessarily need for every project. So there's different ways of considering for that. Then the supported receivers. iOS is really the only constraining part of whether or not a receiver is supported. iOS, Windows and Android are pretty much up for anything you want to throw at it. So if you're going to be using iOS, you want to just make sure that the receiver you will be using is supported for iOS as well. Now, correction services. Pretty much all of us in this room would be needing a correction service of some sort, which I'll go through a little bit more. Now, that correction service might be in the form of a paid subscription service, could be in the form of a base station if you already have one, or if the freely available SBAS real-time correction network will work for your project, you can just use that. But they're all correction services. Datum transformations, that's huge. We need to make sure that we're collecting on the correct datum that our corrections are being provided in. And I'm going to go through that a little bit more in a minute. So a little bit about the receivers that we work with. Now, we have a lot of receivers back at home base in Redlands that we have tested and work with, ranging from survey grade all the way to consumer grade. Again, to tie into that story of, do I need centimeter level if I'm doing manhole covers? Maybe I don't. Maybe I just need sub-meter or sub-foot. So kind of look in the receiver and what corrections are available for that receiver for what you need to use it with. So back to the real-time correction, differential corrections. Again, we're going through considerations to be thinking about before, or if you're already in the middle of a high accuracy collection, to be thinking about. Obviously, we know that these improve accuracy from a receiver. That's why we want to use them. But a lot of them requires a subscription or a connection. You may be in an environment where you don't have cellular connection, so using an N-trip connection to a base station isn't going to work for you because you're not going to have cell coverage. So maybe using a satellite-based correction service to where you're in the middle of nowhere, but you can still get that level of accuracy that you need. Those things to consider as well. They optionally, a lot of them use a third-party app that you need to configure those correction services through to be able to get those corrections, and then Collector will consume that accuracy from the third-party app. And you need to understand your map's projection. And this is going to get into my next point about setting up the datum transformation. What datum do you want to use, and where does that data? How many datum transformations are you persisting through your entire workflow, from maintaining it in the desktop in the office? You may have a transformation in desktop, and then you have another transformation that gets added into ArcGIS Online, another transformation that you add into Collector, and all of them have different levels of accuracy on them. So that goes into my next slide about where do transformations exist in a workflow. Now for Collector, we're looking at DT1. That's where you're going to be configuring the datum transformation on the app side. But that doesn't mean that you should ignore transformations that you're using elsewhere in your software. I'm not saying to not use them, but if you can because every transformation that you incorporate does have a separate level of accuracy with it. That's going to affect what accuracy you get from your receiver. So what I'd like to show you, if you haven't looked at this documentation before, is I'm going to go here. If it lets me. No! That's okay. I anticipated this. No! Respond. Yeah. Let's just restart it and I'll get right back. Wow. It is locking me out. Okay, so this is also part of the demo. How do you end a PowerPoint that doesn't work? All right. All right, should be good. But I want to go do this, so I'm going to go back to here. Okay, so how many of you are familiar with the Geographic Transformations PDF? Have you ever opened up these docs before? They're available in our online documentation, but what I wanted to point out with the importance of transformations is that you have, see this accuracy column? So these are the levels of accuracy associated with the We're just going to skip that because I can't, my computer's freezing, but this still works, so we're going to use this. But anyway, back to my point. In the PDF I was trying to show you, there's a column for every level, every transformation you choose that's called accuracy. That has a different level, it's in meters, that has a different accuracy associated with it. The one that I'm using for my demo that I'm going to be showing you has a 3 centimeter accuracy associated with it. So even though my receiver that I'm going to show, I get 1 to 2 centimeters, that's plus 3 centimeters because I'm using this transformation in the app. So you just want to be cognizant that whatever the receiver shows you may not be what you're actually getting if you're using a transformation. So if you can reduce any transformation in this workflow to use maybe a base map that's in the same projection as the operational layers, that might help reduce where this inaccuracy can be introduced. All right, so let's go into collector setup and let's hope this works. All right, so we're going to go into some settings and see how we can kind of set this things up we need. Okay, so this is just kind of the settings, similar settings that you get in the current version of Classic Collector, but we're going to kind of go through a few of them. Now, I'm going to start with our required accuracy. Now, this is where you would define, this is basically a filter. For any accuracy that falls outside of this range, you won't be able to collect it. So this would be a realistic value that you'd want to set up for your receiver. So if you're only ever able to get 30 centimeters, you don't want to set it to 10 centimeters because then you'll never be able to do a collection. So I'm going to go back and actually change my units I'm going to change them to metric. So let's go back and we're going to change our accuracy to 10 centimeters. Because I know the receiver that I'm going to be using is capable of getting better than this. So I don't want anything worse than that. So I'm going to restrict it to that. And also what you'll see in here is this 95% confidence interval. A lot of companies have a requirement to report accuracies in 95% confidence interval. So if that's a requirement, you can just turn this on and then it will report the accuracy correctly that you need for your reporting mechanism. So let me go back to other settings. So we also support GPS averaging. So if averaging is a lot of times the requirements for averaging is also necessary as well. I'm not using them for this project, for my demo, but if you need to, you can turn them on and control how many points you need to do an average. So kind of just pointing out where things are. But let's go down into the location profile. So this is where you would set up your datum transformation. So we're going to kind of go through this workflow. We're going to go to add. The first coordinate system that I choose is from the receiver. This is, the correction service. So if you're using a base station, if that base station projects data in AD 83-2011, that would be the datum you use here. So I'm going to go ahead and choose what I'm going to be using. And then this is your map coordinate system, which is defined by your base map. So if your base map is using an Esri base map, it'll be in Web Mercator. So that's what I'm going to be using for my field data collection. So we're going to do 857. So this is your area of use. In that same PDF document that I couldn't show you, there's also an area of use section where we define your list of transformations based on your area and accuracy. So we're going to go ahead and just choose, in this particular case, I can choose, because I'm here, I can choose the location tool to take me to my location. And then this is my list. I'm going to choose the most accurate one that I have available in this list, which is the top one, which has a 3 centimeter accuracy, published accuracy. So I'm going to go ahead and then done, give it a name, and then I'm done. You can go back and you can switch to it, and then I'm going to review the settings for it. Now, one thing I want to show quickly that I have, let me flip over here and get my notes, is let's just say if we also support grid transformations as well. So I want to show you kind of what that experience looks like. I'm not going to download them, but I'm going to show you kind of what they are. So let's say if we're using ETRS 1989, and then you want to go to, like, say, British National Grid. We're going to go over here. We're going to choose our area of use, roughly. Next. And then you see we have this download icon. So if you're using grid-based transformations, you can download them to your device, so you're not just, so you have that access, or you can sideload them. We have workflows for that as well. But I'm just wanted to show that so you can be familiar that we do have that support. Okay? And I think that's, okay, done. Okay, so now we have our setup done. So let's go back to the presentation. So we're set up, we have our profile set up, we have our required accuracy set up. Now we're going to go back here. Okay, so now this is the demo that I did. So to give you kind of some background, so I am using a Trimble R2 that's pole mounted, that's using the cellular connection from my phone to connect to Esri's base station with the profile I just set up. So I'm not going to go through that again in the video because it's using the profile that I just showed you. So let's go ahead and get this one played. There you go. So what I'm doing now is I'm pairing the receiver Bluetooth. I'm starting cold so you guys see the whole thing. So the Bluetooth receiver is on. I'm waiting for it to connect. There we go. So it's paired. Wait for that to connect. And then we're going to go back over to the app. Okay. So now what I'm going to do is open up I'm going to go into my settings and I'm going to go to my provider. I need to tell Collector to use that Bluetooth connection. So it's not automatically going to pick it up. So I'm going to go to Add. I'm going to pick my Trimble unit that I've added. And so this is the area where I enter my pole height. And you can see right here that in Collector for Trimble receivers, we've integrated the RTK settings. So you can type and enter in an N-trip connection, or if you're using like direct IP, you can enter that in directly into the app itself. So you can see I'm using my N-trip connection. I chose my mount point. If your mount point is secured, you would get prompted for credentials at that point. Mine isn't, so we can just go ahead and use it. So now we're in the app, and I'm waiting at the top. You can see my accuracy is not very good, so I'm zooming in. And I'm collecting a meter cover that's in the street because I don't want to get arrested for opening it. So we're just going to use it as a cover for now. So I'm waiting for my accuracy to get down. I'm at RTK float. You can see it going down, it's spinning down, and it will switch to RTK fixed. And you can see I got 1.5 centimeters with the R2. So that's good enough for my accuracy. That's really good, so I'm happy with that. Now I'm going to go ahead and just walk over to where my manhole cover is, not get killed with a car. Luckily, this isn't a very highly traveled road. You can see in Collector, we also show labeling for the pipeline. This is a water network that I have. So I'm just going to collect just a system valve. Let's go ahead and open up the pop-up display. in the sliding panel. I'm going to fill it out with some attributes. Just for this particular case, it's not super necessary for this part, but just go ahead and just fill these out real quick. You can see I have all my coded value domains, my pick lists. You can enter the date. This is a new valve. This is a new valve, so I'm saying it's not inspected because I just installed it. So we're going to go ahead and just give it an ID for whatever new valve this is. So you can do the same if you're doing inspections as well. So a lot of times these valves, I don't know from experience, but I've heard that a lot of times these valve covers get paved over. So even though the cover itself is maybe like 10 centimeters in diameter, knowing exactly where it is if it ever does get covered, or if you're in a situation where you have ground cover, like snow, knowing where it is there. And you can see I took a picture of it. You can see it in the pop-up display. I'm submitting it, waiting for that to get done. And then now we're going to go back and we do capture metadata. There's 18 fields worth of metadata that you can add to your schema to capture with a GPS receiver, and I'll show you what those are in a minute. 4 of them are unique for averaging. So if you're not using averaging, you don't need them, but they'll add them anyway. So you can see I'm going through, I have my receiver name, I got my accuracy that's in meters. You can see I have my lat long, I got all the PDOP fixed types. So this is beneficial if you want to go back into the office to do any type of decision making or analysis with this data. You have the raw metadata. So now I'm done with this particular valve, but let's just say I have another water valve that I want to inspect. So, but I don't necessarily know where it is. So I'm going to do a search with a barcode, and I have a barcode just printed out that I have. You may have a binder of barcodes. So I'm going to scan this. This is a valve ID. So I'm going to search for it, and it's going to find it on my map. Right? And then now what I'm going to do is I'm going to use what's called compass mode to give me the bearing and distance to that valve. Especially if these are water valves, you may have them really tightly coupled. So coupled with the fact that I'm getting 1.4 centimeters will take you to the right valve you need to make sure you inspect or repair or whatever the case may be. So you can see I have a leader line from my location to that valve with a bearing and distance in the GPS banner at the top. So that, as I walk to it, which I'll show you in a minute, I'm not going to walk 89 meters, but that is, it'll get closer and it will change direction with where you need to go. Now, if you don't know, if you're like, this would even work if you dropped a pin. If you knew where you need to go on the map, but you don't have a feature there yet, you can just drop a pin on the map and it would compass navigate you to that location as well. So then you can see kind of that's where that's at. Okay. So I want to kind of quickly point out using what the downfalls of using an incorrect location profile will be. Basically, it'll just be a datum shift. And you'll know that it's an incorrect profile if all your data is shifted to the same direction by a similar offset. So you can see in here, I'm not using the profile that I set up before. So the red point in the bottom right, that's about 3 meters off because that's just the offset between WGS84 and NAD83. So that's where that 1.27 meter offset is because I didn't use the right profile when I collected my data. So you would see something like that. Okay, so now we're going to kind of switch gears a bit, and we're going to discuss configuring Collector Classic for offsets. So so this functionality is currently supported on iOS, and is currently only supported in Collector Classic. We haven't yet ported this functionality over to the new one I was demoing, so we're going to kind of go back to the old app to show you this functionality. So this functionality is supported with EOS GNSS receivers. So you would need that type of receiver to support this workflow because this is mostly done in their app. But I want to show you this functionality that it's a ability that Collector does support currently with this receiver. So it would need a laser rangefinder. And in the case of using iOS, and we have an angle encoder because this particular rangefinder doesn't have a built-in compass. If you want to get the different, the azimuth, then in this case, that setup that you see in the picture, we actually have that back in the office. Kind of looks like a total station type of a setup with the receiver on the top. So it's for Collector Classic for iOS, and it uses the EOS Tools Pro app. So we use app integration from Collector to EOS Tools Pro. We're basically, and I'll show a demo of that, how that works. There's 3 methods that are supported, 3 offset methods that you can do with this workflow. You can do the standard laser offset method, which is where you stand with the laser rangefinder and you shoot it and it Bluetooths to your device. You can do range backsite, which is the method I'm going to show you, or you can do range offset. And they have their benefits and their pros and cons for each of them. So let's discuss the range backsite offset method. Equipment, you need a GNSS receiver, you need the laser rangefinder, and the angle encoder. Basically, for this method, you need that whole setup that I showed you. So what are the steps? So let's just say you're trying to capture an offset that's in the middle of an intersection. I know oftentimes it's hard to get clearance to close a road. It's also dangerous if you stand in the middle of a busy intersection. So you may just want to shoot a manhole cover from a safe distance using an offset. So you don't have to, do all of that physically at that location. So the first thing with the range backsite method, you would capture the backsite. And now, bear in mind that you'd want to make sure that the backsite and then eventually the control point have visibility to whatever you're shooting. So you don't want to do it around buildings where then you can't see and clearly fire what you need to fire. So capture GNSS backsite point, then you pick up the device, move it over to the control point, capture the control point. Then from the control point, you turn the rangefinder back to the backsite, you fire the backsite method, and then you go to the target. Then you go back. Now you've set your 0 at the backsite, and now you can get the correct azimuth as you go to the point. So I'm going to go through a little video of how this works. So it's already playing. So you can see we've already set it up, and we're going to use method 2, backside offset method. So now you can see we go use offset from location. So it's going to fire into their app. And we're capturing the backside point now, and we're going to average it to 5 locations. So this is in the EOS Tools Pro app that we've reached out to. We're going to go to step 2, which is moving it to the control point, where we actually are going to fire the target from. We're going to hit start, and we're going to start averaging from this location as well, same as the backside point. So you're getting that level of accuracy from your control point, so that you can maintain that accuracy for your offset location. Now we're going to do angle calibration, which is where you fire from the control point back to your backside point to set your 0. And we're going to do that in a minute. And we're going to see that that will populate from the app. So this is very easy to follow. It's very stepped through with each method. So if you're using range, it'd be a similar experience where you'd have to capture one point and then another point. So you can see there's our distance from the control point to the backside. Now I'm going to fire at my target, which is my manhole cover. And you can see I'm going to get my slope distance and my azimuth, and then we'll get the inclination. And then all of this will be sent back to collector in metadata. So you can see now I'm back in collector, and you can see the point was offset to the right. So now we'll see, I'm submitting it, and I'm going to get the offset from the slope, from the offset. So I'm going to get all the metadata. I didn't focus on it, but we would have the different lat and long, you'd have the update, you have the slope distance, all that would come from EOS Tools. So we're kind of swapping information back and forth. So kind of an overview of the different methods. I had some time, I want to throw this in there quickly. You have the standard laser offset method. So a lot of these are like highly mobile, like you can walk very easily, but they're not very accurate. And then some of them are like, okay, now I have a lot of equipment I got to carry, so I can't really go into all these locations. But you can see that it's highly accurate. Kind of the range backside method is highly accurate. It's not as easy to use because you have to use all this equipment. You have to set it up, you have to level the tripod and all that kind of stuff. So it's a little challenging if you just need quick offsets. So let's kind of switch over here. So what's coming in collector for high accuracy right now? So I'll come back to the orthometric heights in a second because I want to talk a little bit more on that one. But right now we do have an Android beta, and we're actually hosting a holistic event. That's an online holistic event next week. So if you have the ability to participate in this event, we can sign you up, and you can test high accuracy. You'll be able to test tablets and phones, so you can kind of give us some feedback on your workflow. If you're mainly an Android shop and you want to use the new version of Collector, you can give us some feedback on that. So feel free to stop by the booth, and we can sign you up if you're interested in participating in that event. It's the 13th and the 14th next week, and you can test from it back in your office, so you don't have to physically be here. So support for capturing orthometric heights. Right now in Collector, we do support capturing Z values, but we don't have support for vertical datum transformations. So if you were to say, look at the Z component of a collected point, it would have a Z value on it, but it would just have come from the geoid model that's built into the receiver. That may not be as accurate as what you want. And that's what we have currently until we get support for configuring a vertical datum transformation in the app itself. That's what is coming, and that's what we're going to be working on. As you saw with the metadata, I do capture altitude. That's ellipsoidal height. That's not orthometric height because that's raw from the receiver. We do have back-end post-processing methods, and we can come by the booth and I can tell you that. There's a tool we developed called Project Z, where we could actually use the datum transformations in ArcGIS Desktop to take the altitude and give you a mean sea level height or orthometric height from that value. So we have a way for you to get orthometric heights, just not directly in the app right now. That's what's coming. So we're excited about that. So that's about it. Anybody have any questions? I don't have anybody behind me, so feel free to answer as many as you want. Just for lunch. I know you guys want to leave and go eat lunch. No problem. And I'll be at the booth if you don't answer them, ask them here. But go ahead. So you're asking what support? Okay, so I think, and correct me if I'm wrong, but the question is what version of iOS does Collector Classic support? The minimum version for Collector Classic is 9.3. 9.3 for Collector Classic, up to the current version, iOS 12. If it's Collector, the new one, Collector Classic goes back further to iOS 9.3. But the new version, Collector minimum is 11. So if you want to use the new version of Collector for ArcGIS, you need iOS 11 minimum. But Classic can go back further than that. So, any other questions right now? No? Awesome. Cool. Thank you guys for attending. Again, if you have more questions that come up, I'll be at the booth. Thank you very much.